Dear students, today we will discuss about the semiconductor, phototransistor and the LDR. These are the also semiconductor devices and which have the many applications in the field of electronics. So what is the phototransistor? The phototransistor is a semiconductor light sensor formed from a basic transistor with a transparent cover that provide much better sensitivity than a photodiode. What is the phototransistor structure or construction of phototransistor? The phototransistor has much larger base and collector area than would be used for a normal transistor. These devices were generally made using diffusion or ion implantation. So, in this structure of phototransistor of this diagram, early phototransistor used germanium or silicons throughout the device, giving a homojunction structure. The more modern phototransistor use type third and fifth materials such as gallium and arsenide, and the like heterostructure that use different materials either side of the PN junction are also popular because they provide a high conversion efficiency. These are generally fabricated using epitaxial growth of materials that have matching lattice structures. These phototransistors generally use a Mesa structures. So sometimes a Schottky metal semiconductor junction can be used for the collector within a phototransistor. Although this practice is less common these days because other structures offer better levels of the performance. In order to ensure the optimum conversion and hence sensitivity, the emitter contact is often offset within the phototransistor structure. This ensures that the maximum amount of light reaches the active region within the phototransistor. So this is the also a structure of phototransistor in this diagram. What is the phototransistor operation or working principle of phototransistor? Phototransistors are operated in their active region. For operation, the wise conditions are quite simple. The collector of an NPN transistor is made positive with respect to the emitter or negative for the PNP transistor. So we use here two type of transistors. One is PNP transistor and also second is NPN transistors. The light enters the base region of the phototransistor where it causes whole electrons pair to the generated. So due to the base region of the phototransistor where it causes holes electrons pair to be generated and holes and electrons pairs generate the currents in this device. This many occurs in the reverse bias base collector junction. So in this case, we keep the base character junction as a reverse bias condition. So here is a symbol of photo transistors. The whole electron pairs move under the influence of the electric field and provide the base current, causing electrons to be injected into the emitter. So, what is the phototransistor characteristics? Characteristics means the relation between current versus voltage. The phototransistor has a high level of gain resulting from the transistor action or homostructure once using the same material throughout the device. This may be of the order of about 50 micro to few hundred. However, for the heterostructure devices, the level of gain may be rise to 10,000. Despite their high level of gain, the heterostructure devices are not widely used because they are considerably more costly to manufacture. The characteristics of the phototransistor under different light intensities. So we use the different light intensity in the characteristics of phototransistors. They are very similar to characteristics of a conventional bipolar junction. And what the different levels of base current replaced by the different levels of light intensity. So in BJT, the base current we use and the in phototransistor we use the light intensity. There is a small amount of different that flow in the phototransistor even when no light is present. This is called the dark current. So the value of dark current is very minimum in the range of nano ampere or microampere and represent the small number of carriers that are injected into the emitter of this current or this dark current flow due to the magnetic carriers that are injected into the emitter region. So what is the advantage of phototransistor as compared to BJT, bipolar junction transistor? So a further advantage of all phototransistors when compared to the avalanche photodiode, another device that offers gain is that the phototransistor has a much lower level of noise. So in phototransistors, the noise is very low and we have some disadvantage of the phototransistors. One of the main disadvantage of the phototransistor is that it does not have a particular good high frequency response. So in phototransistor, there is not good frequency response. This arises from the large capacitance associated with the base collector junction. And this junction is designed to be relatively large to enable it to pick up sufficient quantities of light. For a typical homostructure device, the bandwidth may be limited about 250 kHz. Hetero junction devices have a much higher limit and some can be operated at frequency as high as 1 gigahertz. So this is the very high frequency, 1 gigahertz. Phototransistor symbol. So this is the phototransistor symbol in this symbolic diagram. The phototransistor symbol for use in electronic circuit diagram is very straightforward. It is formed from the basic transistor symbol with arrow point into it to indicate that it is light sensitive. So arrow points into this device indicate that is the light is sensitive. The phototransistor symbol often has two arrows pointing toward it. What other phototransistor symbol show a jagged arrow. Both versions of the phototransistor symbol are acceptable and understood. So this is the phototransistor symbol. And next, what is the phototransistor circuit configurations? So configuration is the very important parts of any semiconductors device. The phototransistor can be used in variety of different circuit configurations like more conventional transistors. The phototransistor can be used in common emitter and common collector circuits. Common base circuits are not normally used because the base connection is on left floating. So in phototransistor configuration, generally there are two types. One is the common emitter and second is the common collector circuit. And common base circuit are not normally used because base connection is often left floating. So there are only two configurations. The choice of common emitter or common collector phototransistors circuit configuration depend upon the requirement for the circuit. The two transistor circuit configuration have slightly different operating characteristics and these may determine the circuit use. So first is the common emitter characteristics or common emitter configuration of the phototransistor circuit. In the common emitter phototransistor circuit configuration is possibly the most widely used, like its more conventional state transistor circuit. The collector is taken to the supply voltage by a collector load resistor and the output is taken from the collector connection on the phototransistor, and also we can see this the diagram of common emitter configuration circuit as shown in this figure. The circuit generates an output that moves from a high voltage state to a low voltage state when light is detected. The circuit actually acts as an amplifier. The current generated by the light affects the base region. This is amplified by the current gain of the transistor in the normal way. So this is some fact about the common emitter characteristics of the phototransistor circuits. Second one is the common collector phototransistor circuit configuration. In common collector, we can also, as shown in this diagram, the common collector or emitter follower phototransistor circuit configuration has effectively some topology as the normal common emitter transistor circuit. The emitter is taken to ground by a low resistor and the output for the circuit being taken from the emitter connection. of the device. The circuit generates an output that moves from the low state to a high state when light is detected. In this diagram, so these are the some specifications and fact about the common collector phototransistor circuit comparison. And next, what is the phototransistor circuit operation or working principle of the phototransistor? So the phototransistor circuit can be used on one of the two basic modes of operation. They are called active or linear mode and switch mode. So basically here two basic modes of operation. One is the active or linear mode and second is the switch mode. So in first operation in the linear or active mode provide a response that is very broadly proportional to the light stimulus. In reality, the phototransistor does not give a particular linear output to the input, and it is the for this reason that this mode of operation is more correctly termed the active modes. And also the operation of the phototransistor circuit in the switch mode is more widely used in view of the non-linear response. So this is the second mode of the phototransistors. Phototransistor to light. When there is a little or no light, virtually no current will flow in the transistors, and it can be said to be in the off state, where there is no current flow, that is the off state. However, as the level of light increase, current start to flow. Eventually, a point is reached where the phototransistor becomes saturated and the level of current cannot increase. In this situation, the phototransistor is said to be saturated, and the switch mode therefore has two levels. One is on and second is off, as in a digital or logic system. So digital or logic system, we have two levels, on and off, low or high. This type of transistors, phototransistor mode is useful for detecting objects, sending data, or reading encoders, etc. With most of circuits not using the base connection, even if it is available, the only way to change the mode of operation of the circuit is to change the value of the load resistor. This is set by estimating the maximum current anticipated from the light levels encountered. So using this assumption, the following equations can be used. For the active mode, the BCG or biasing DC voltage is greater than RL into IC. That is the active mode. And second is the in switch mode, the BC is less than RL into IC. So these are the two assumptions. One is the active mode, second for switch mode, where RL is the load resistor and RC or RE in the diagram above, and IC is the maximum anticipated current, and BCC is the supply DC voltage here. So next, Semiconductor electronics device is the LDR, light dependent resistor, LDR. So what is the LDR? The LDR works on the principle of photoconductivity. Photoconductivity is an optical phenomena in which the material's conductivity reduces when light is observed by the material. So this is the optical phenomena in which the material conductivity reduces when light is observed by the materials. When light is fall, when the photon fall on the device, the electrons and valence band of the semiconductor materials are excited to the conduction band, and these photons in the incident light should have energy greater than the band gap energy or forbidden energy. So the semiconductor material to make the electrons jump from the valence band to the conduction band. In this case, when light is incident, and that case the energy greater than the band gap energy. In this case, the electrons jump from the valence band to the conduction band. So due to this, the current flow, due to the charge carriers flow from valence band to conduction band. And when light having enough energy is incident on the device, more and more electrons are excited to the conduction band, which result in large number of charge carriers, and these are the majority charge carriers. In that case, the result of this process is more and more current start flow, and hence it is said that resistance of the device has decreased. And what is the characteristics of LDR? LDR are light dependent devices whose resistance decrease when lights fall on them and increase in the dark. So the LDR is the light dependent resistance device whose resistance decrease when light fall on them and increase the resistance in the dark region. So when a light dependent resistor is kept in dark, its resistance is very high in dark region. This resistance is called a dark resistance. So it have the very high value, 1012 ohm approximate. If the device is allowed to absorb light, its resistance will decrease drastically, because the resistance depend on the intensity of light that is observed by the LDR. So in this diagram, that diagram show the characteristics of LDR between resistance versus intensity. In a constant voltage is applied to it and intensity of light is increased, the current starting increasing. When light is incident on a photo cell, it usually takes about 8 to 12 milliseconds for the change in resistance to take place, while it takes second for resistance to risk back again to its initial value after removal of light. So this phenomena is called as a resistance recovery rate. LDR are less sensitive than photodiode and phototransistor. The photodiode and photocell LDR are not the same. Photodiode is a PN junction semiconductor device that converts light to electricity, whereas photocell is a passive device. There is no PN junction or nor it converts light to electricity. So is the difference between the photodiode and photocell LDR. If the light intensity is kept constant, the resistance may still vary significantly due to temperature changes. So they are sensitive to temperature change as well. Extrinsic light dependent resistors are generally designed for longer wavelength of light with a tendency toward the infrared IR when working in the IR range, infrared range. Care must be taken to avoid heat buildup, which could be affect measurement by changing the resistance of the device due to the thermal effects. Modern light dependent resistors are made of lead sulfide and lead selenide. So in this construction of LDR, indium antimonide and most commonly cadmium sulfide CDS and cadmium selenides generally used for construction of LDR light dependent resistor. A light sensitive material is deposited on an insulating substrate such as ceramic. The material is deposited in zigzag pattern in order to obtain the desired resistance and power rating in the construction of LDR. This zigzag area separates the metal deposited area into two regions. Then the ohmic contacts are made on the either sides of the area. So in this diagram, we can see the construction structure of the LDR. The resistance of these ohmic contacts should be as less as possible to make sure that the resistance mainly changes due to the effect of the light only. Highly purified cadmium sulfide powder and inert binding materials are mixed. This mixture is then pressed and centered. The disc is then mounted in a glass envelope or encapsulated in transparent plastic to prevent surface contaminations. So these are the some features about the construction of LDR. Now, what is the advantage of LDR? So there are some advantages. So first one is LDR are cheap and are readily available in many sizes and shapes. Practical LDR are available in a variety of size and package styles. The most popular size having a face diameter of roughly 10 mm. The next advantage, they need very small power and voltage for its operation. So these are some advantages of the LDR. And also highly inaccurate with a response time of about tens or hundred of milliseconds. So these are the some advantage of the LDR. Next, what is the application of LDR? So first application of LDR is a light sensor. The LED light up down up when the intensity of the light reaching the LDR resistor is sufficient. For example, a automatic emergency light, it senses a darkness night and turn on automatically. Similar, it senses daylight and turn off automatically. Series of LED are connected, and we also can see this in this diagram. So these are the some applications of LDR. Next, now we will discuss about the crystal diode rectifiers. These are the application of semiconductor device diodes. So what is the rectifiers? Rectifiers is that circuit that convert AC signal to the DC signal. And the following two types of rectifier circuit can be used. First one is the half wave rectifiers and second one is the full wave rectifier. So first of all, the what is the rectifier? So rectifiers is the convert the AC signal into DC signal, and the rectifiers we can use in two types. First one is half wave rectifier, second one is the full wave rectifier. So what is the half wave rectifier and what is the function of half wave rectifier and how it will work? The process of removing one half the input signal to establish a DC level is called a half wave rectification of half wave rectifiers. And in half wave rectification, the rectifier conduct current during positive half cycle of input AC signal only. And we also understand with this wave rectifier concept with the help of this circuit diagram, and there are different inputs or outputs waveforms. So in a wave circuit diagram, there is the input supply AC, and there is one transformer and one diode and one load resistance. So we apply a sinusoidal waveform to the input of transformer, and after a rectification, the output will be in the shape or output will be in DC voltage in the shape of half wave. So negative half cycle is suppressed. So AC voltage across secondary terminal AB change its polarity after each half cycle. We can also see in this case in this circuit diagram. And during negative half cycle, cycle terminal A is negative in this circuit. So diode is reverse bias, and through the diode during positive half cycle only. In this way, current flow through load resistance in one direction only. So this is the half wave rectification in which AC supply convert into the DC supply or AC signal convert into DC signal in the form of half wave. And what is the disadvantage of half wave rectifiers? The pulsating current in output contains AC component whose frequency is equal to supply frequency. So filtering is needed here in this half wave rectifier. The AC supply delivers power during half cycle only, so output is low. So this is the advantage of half wave rectifiers. But in this diagram, waveform diagram, the output frequency of half wave rectifier is equal to the input frequency, or the frequency is same between input signal and also output signal. This means when input AC complete one cycle, rectified wave also complete one cycle. So frequency, output frequency equal to input frequency in the half wave rectifiers. And next type is the full wave rectifiers. So in full wave rectifiers or full wave rectification, current flow through the load in same direction for both half cycle of input AC supply or input AC signals. This can be achieved with two diode working alternatively. So we use here two diode in full wave rectifier. But in half wave rectifier we use only one diodes. For one half cycle, one diode supply current to load, and for next half cycle another diode works. So two diodes works, one for one half cycle and second for second half cycle. So that is the circuit diagram for the full wave center tap rectifiers. In this circuit there is two diodes, D1 and D2, and a center tap transformer in the circuit. Now positive half cycle diode D1 conduct, or diode D1 is forward bias, and during negative half cycle diode D2 conduct. And first half cycle diode D1 is forward biasing and diode D2 reverse biasing. So in positive half cycle diode D1 conduct and diode D2 non-conduct, and next negative half cycle diode D2 conduct, because diode D2 is the forward bias and diode D1 is reverse bias. So D1 is not conduct. It can be seen that current through load RL is in the same direction for load cycles. Full wave bridge rectifier. This is the circuit diagram of full wave bridge rectifier. So we use in this circuit diagram total 4 diodes, and needs for center tap. Here transformer is eliminated. Here consists of 4 diodes instead of 2 diodes. So in this circuit diagram and different waveforms show the working principle of full wave rectifier. So in this full wave bridge rectifier, during period t equal to 0 to t equal to t by 2, in that case D2 and D3 are conducting. So here two diodes D2 and D3 are conducting, while diode D1 and D4 are in the off state, or these diodes are not conducting. So what during period t equal to t by 2 to t equal to t, in that case diode D1 and diode D4 are forward biasing. In that case diode D1 and D4 are conducting, while D2 and D3 are reverse bias in that case. So diode D2 and D3 are in the off state. So over one full cycle, the input and output voltage will appear as shown in figure. So the output DC voltage will be 2 into 0.318 V maximum and equal to 0.638 V maximum. So this is the output DC voltage of the full wave rectifiers. And also in full wave bridge rectifier, what happens if we use silicon diode instead of a ideal diode? So in this case of operation of full wave bridge rectifier, the output voltage will be VDC equal to 0.636 into Vm minus 2 Vt. In the case of we use silicon diode instead of ideal diode in full wave bridge rectifier. So in the waveform diagram, the full wave rectifier's output frequency of full wave rectifier is equal to the double of input frequency. So in that case, the output frequency is the double of the input frequency. This means when input AC complete one cycle rectified, so what is the advantage of full wave bridge rectifier? So here are some advantages. First one is the need for center tap transformer is eliminated. Second one, peak inverse voltage is 1/2 of that of center tap circuits. And third advantage is that output is twice than that of center tap circuit. So these are some advantages of full wave bridge rectifier. What we have also some disadvantage in full wave bridge rectifiers. So first disadvantage is it requires 4 diodes, and second one, internal resistance voltage drop is twice than that of center tap circuit. So these are some disadvantages of full wave bridge rectifiers. These are some reference books for covering this topics. First one is Principle of Electronics by Emitter, and second Electronics Device and Circuit by Hollister. And also there are some multi-choice questions. So we will discuss about these multi-choice questions. The question first, the current gain of a transistor is defined as the ratio of the collector current to the option A base current, option B emitter current, option C supply voltage, option D collector current. So correct answer is option B. The current gain is the ratio of the collector current to the emitter current. So correct answer is B. Next, the graph of current gain versus collector current indicate that the current gain A is constant, B very slightly, C very significantly, option D equal the collector current divided by the base current. So the graph of the current gain versus collector current indicate that the current gain is constant, but this is very slightly. So correct answer is option D. And there are also some questions. Thank you. Thank you very much.